Greetings everyone, we are sarcastic individuals here, and today we're presenting the mathematics behind columns. The first observation that we can make is that columns are constructed from a set of points arranged in a two-dimensional grid. This grid becomes the very foundation of every column, since each line and curve is drawn in relation to these points. The second observation is that columns are formed using a set of fundamental curves. These curves fall into three main subtypes, as you can see, and each can be identified within the column designs. And by adjusting their parameters as I'm doing so on Desmos, they can bend, loop or straighten, giving rise to the variety of shapes in columns. Next, we model a column as being divided into layers of radially symmetrical objects. Suppose we have n plus 1 layers written as L equals L0, L1, etc. until Ln. The innermost layer, L0, is the center point of the column. In this example, there are three layers, a central point, a triangle, and a hexagon. Now, let Pi be the number of points in layer Li. A key rule is that Pi must divide Pi plus 1. This ensures that each point in the inner layer can be mapped to Pi plus 1 divided by Pi points in the outer layer. These connections are represented as imaginary lines, not part of the final column, but essential in the construction of it. Using these imaginary lines as major axes, we can then draw the curves that was aforementioned. To maintain symmetry, each layer chooses one of the three curve types randomly with random parameters so that all the curves in a layer are consistent. Finally, when we remove the construction objects like the polygon outlines and the imaginary lines, what remains is the column itself, symmetric, elegant, and mathematically precise. From an algorithmic point of view, the nearest distance heuristic and the curve choosing algorithm can be further modified for better results, allowing us to generate columns that are more balanced and aesthetically refined, like these. In summary, columns can be explained as layers of symmetric points mapped through rules of divisibility, connected by imaginary lines, and are completed with carefully chosen curves, giving us a framework to computationally recreate this traditional art form. Thank you.